Okay, good morning, good evening, good afternoon, wherever you are in the world, wherever you're joining us from. We're going to give people a few minutes to join before we get started. A little game we like to play while we're waiting for people to join the session is to put into the chat window where you're joining us from. So I'm going to get started off here by typing in where I am joining from.
Oh, there it is. Oh,
beautiful Sanford, Michigan, where it is cloudy, gray, and wet right now.
Uh-huh.
I'm sure Kalamazoo's not much different, is it, Jason?
Indeed, it is not.
Well, so far it looks like we have a pretty small group today. Well, let's go ahead and get started, and people can join us if they get the chance. So welcome to another community conversation hosted by the Autodesk community. My name is Chris, and I'll be your community host today. It is my pleasure to welcome Richard and Jorge, who will be taking all of your Fusion Electronics questions today. Just a little bit about this series for anyone joining for the first time. Community conversations are virtual meetups featuring expert speakers from across the Autodesk community. Sessions range from deep dives, tips and tricks, and live demos on products to roundtables on industry highlights, emerging trends, career stories, and much more. All experience levels from beginner to expert are welcome. And just a quick mention of our safe harbor statement. If anything forward-looking is mentioned during this session today, this statement basically says, do not consider these to be any kind of a guarantee, but if you're making purchasing decisions on software, look at the software as it exists today only when making that decision. And just some quick clean up stuff before we begin. All lines are muted, but we do want to make this a conversation. So if you have a question, please post that in the chat or use the raise hand function, and we'll be keeping an eye on that throughout the day to make sure that we can get as many questions as possible. We are recording the session, and a link to the recording will be sent out shortly after the session is completed. As I mentioned, my name is Chris. I am the Community Manager for Design and Manufacturing here at Autodesk, coming up on my 2 years pretty soon here in a couple months. Prior to that, I was a machine designer, Vault Administrator, and Autodesk Expert Elite, and a speaker at Autodesk University. I'll hand it over now to Richard and Jorge to do a quick introduction, then take control of the session. Gentlemen?
Okay, yes, so I'll just want to introduce me. Okay, I'm Richard. So I'm a long-time companion of Fusion Electronics from the start, and before that, a long-time companion of Eagle. I started, I hardly can remember, 28 years ago with Eagle at CADsoft, and yes, did all you could imagine about support, documentation, all around Eagle. And later, of course, we have been acquired by Autodesk. And maybe you followed us the last 4 or 5 years now with development in Eagle, and now we have electronics in Fusion. Since 2 years ago, I think we implemented it, yes. And so, well, at Autodesk, I started with the same job as I did in CADsoft. It was more or less support. We had to train people, support staff to build up their knowledge, and now I'm a so-called community specialist for electronics. So that's something, talking to people inside and outside of Autodesk about electronics. I want to understand how you're working with electronics. Our people want to understand what electronics can do, and how we think, the customers. And so that's my role to how to make electronics great in Autodesk. Let's make it this way, put it this way. Yeah, basically, if you have questions in the forums, for example, you will find me, and of course Jorge. You're the forum guy here. I think nobody else than you has so many posts in the electronics and Eagle forums. So so I hand over to Jorge to introduce you.
Hello everyone. My name is Jorge Garcia. My role is similar to Richard's. I came on with CADsoft about 12 years ago now, I think, if I remember correctly. And since then, it was the same thing: support, talking to customers. Within Autodesk, my role is basically electronics help. Any internal issues with Autodesk with electronics. So if there's questions, if any of the Autodeskers need help with electronics, be it with a customer or an internal project or something like that, then I usually help on that capacity. But our main goal in this community conversation is to gather feedback. You know, what do you like? What don't you like? And then be able to integrate that into our development and what's going on within Fusion 360 Electronics. So feel free to ask any questions. Feel free to give us any comments, good or bad. We want to hear them because all of this is going to help us make Fusion 360 Electronics better. So with that, we can go ahead and get started. We do have a...
Turn off my sharing here so you guys can take control.
Thank you.
Okay, thank you.
So Richard, I think you wanted to start first, but if there's any comments, if anybody has anything they want to ask before we do it, because we have a couple of little demos. If anybody wants to comment anything before or have a question before, that's really what this is about, you know. So
if there are no questions, maybe somebody wants to answer my question. Who of you is familiar with Fusion Electronics, or who is working as an electronics design engineer? So that would be interesting. Or is there, let's put it the other way around, is here somebody who is really new to all this? That's also interesting. So because I would like to know what you think, what you're doing. So that would be also interesting. Meanwhile, I could share my screen. I just wanted to show a few things in electronics. So let me just find the right button. Okay, I have to move this away. Just a second.
By the way, feel free to just open up your mic. If we had a lot of people, then it'd be harder to control that. But feel free to just open up your mic, say hi, and you can just ask whatever question you may have.
Okay. Yeah. Okay. Cool. So now you see. I guess I see my screen. That's the electronics design document in Fusion now. So depending on the participants that are here, I could also share a slide before. No, I guess you're all familiar with electronics, and now I switch into my schematic. What I want to show you, and that's something that came up in the conversation recently with a customer, and because I think I did an introduction about a year ago, and they decided to go for Fusion Electronics, and they did a follow-up recently, and they said, hey, what are you thinking about the schematic? What do you like? And there also have been Eagle users. And I said, yeah, schematic, that's working perfect, so no problems at all. And then I said, oh yeah, so I see you like the way how the nets behave when you move something. And so if you maybe know Eagle, and let me just take this area here. You're used as an Eagle user. Let me go here, design. I use the move command. Sorry, I have to look to the other screen here. And I can move, for example, this component here, this one. And what happens if I move it up? You see the nets are following, and so you can easily move it around, and you don't have to realign the nets. And if I go here, you see it really perfectly follows my design, so I can easily move something down here, and the nets come down with me, and they keep their orientation, and that's a really nice improvement. And the guy said, okay, I didn't notice, it's running so smooth, I even didn't notice. And how was it in the older versions? I think I have to switch it here, and I go there. Now that's what you are used to see if you move something. So I move this away, and then I have to start to realign. And that's something that's really cool now in Fusion, since, I don't know, a few releases. ago we introduced this, and so that's much more convenient. That's one of the nice things I wanted to show. The other thing that might be interesting, you know, we have some big improvements in routing capabilities. So maybe I show you a short slide here. I hope this works. Yes, so yeah, we have different options. So we have route. Yeah, you can, of course, you know, route manually. So take this AirWire and route it as you maybe know it from other tools. You could have differential pairs. You could also route a bunch of signals at the same time, and you start them, go through the design, and drop the signals or finish the signals. And we have the same as in Quick Route. Quick Route is more convenient. It's more, how should I say, is it half automatic maybe? You click onto an AirWire and it's laid out. The same for a whole signal or even for multiple signals. And what I would like to show you is that's really nice. It's the Quick Route Smooth. And there is also a guided tool where I can decide or define where the traces have to go. That's also nice. And we have an auto router. I don't want to mention the auto router today. It's something, it routes all the signals automatically. But I'm not, that's my personal opinion. I'm not really a friend of auto routers because you do not really have control over the signals of the path they use. I don't know, Jorge, how do you see it?
So basically I look at the auto router just like any other tool. You need to know when it applies and when it doesn't. The problem with auto routers is that people tend to treat them like a silver bullet. Like, oh, it'll just do the work for me and that'll be good. But if you just use it blindly like that, then you may be using it in circumstances where it doesn't apply, and that's where customers get in trouble. You know, the auto router should not be used to do anything that's high frequency, high power, anything that has critical signals. If you do medical, for example, you know not to do that because the auto router just isn't aware of all of the design decisions that need to be made to make sure the board is functional. If you have, you know, let's say, you know, a 10 amp line and it's right next to a trace that's carrying a heartbeat signal, you could kill somebody, you know. The auto router isn't aware of that. So as a designer, you are aware of that and you know that you need to handle that manually. So that's something that's my opinion on it. Basically, it's a tool like anything else, but if you abuse it, you're going to get into trouble. And it's a very easy tool to abuse. And that's what tends to happen with them.
Yeah, I see it the same. And I think you have much more control if you have some semi-automatic routing tools as the Quick Route is, for example. So I really see what's going on and I can easily change or react on this. And if I'm running an auto router, I have to wait until it's finished and then I say, okay, the result is quite good maybe, but I have to change here and there. And maybe there are more sophisticated routers there have much more options maybe for configuration, but it takes a lot of time to find the correct configuration. So I'm really I'm pro manual routing. Yes, and route and move, that's one of the things I also want to show you. So because, you know, yeah, we can push violators or walk around of them, and that's not just in the routing process, it's also when you move something, if you move a component, and I think that's something really unique we see in electronics, in fusion electronics. So I try to stop the slide, go back here.
There's an auto route feature on piping in Inventor that I used quite a bit over the years, and just as a thought going forward for you guys, one of the things they incorporated was once you use the auto route tool, you had a quick way to convert it to a sketch so that you let the system give you the auto route and then you take control of it after that and you can do whatever you want with it.
Yeah, in electronics, a lot of users do it that way. They'll just let it run a first pass and then they'll edit that pass. that's a
And you
matter
get
of,
the best of both worlds. You get the system giving you the initial look at it, and then you get to take control from there.
yeah.
Yeah,
Yeah,
right.
it's a preference thing. I've dealt with customers that like that. Others are like, if I let it run, then it's going to be more work for me to fix it. So you get that school of thought kind of jumping in also. So horses, what is it? Courses for horses, something like that.
So we did have a question from Ronald. I don't know
Yeah,
if you want to address that
yeah, we could
right
address
now,
this
or do you
of
want
course
to?
here. Yeah, sure. So I see. Okay, it's about the ANSYS connection. I know Ronald where he comes from. I know why he's asking this. Okay, so yes, what can we say? So there is a connection. We are planning this. It's on the road. So the goal would be, how can I describe it? In the first phase, we already have an export for ODB++, and we have an export for what's the file format, EBM or something like this. So that's a file
Yeah, the
format
ANSYS.
that can be consumed by ANSYS. We are on the way. We need some more. Yeah, EDB. Thank you. That's it. So we are on the way to have more. Yeah, we need some more content to really simulate something in ANSYS. So what we would need to have, we would need information about the material we have, the board materials, the layer stack up. And these are all things that we are working on. I think we can say this because if you can read between the lines, then you know that we need this. So there will be a kind of, layer stack manager containing materials and all you need. And then we want to have ANSYS simulating for us. How this will look like exactly, there are plans. I'm not. Yeah.
Remember, Richard, that Chris at the beginning put that safe harbor statement, so
I know the safe harbor statement. Yes, I know.
You can feel pretty safe to give more ideas if you want.
I can't tell you anything. No. I guess the plan is to. Yes, to have ANSYS doing the simulation, and in a final step. So that's not in the next releases, but in a future perspective, it would be nice to have you designing a layout, and it would be nice to see in the background some calculations that already maybe evaluates what you're doing in the board. That would be great. And I do not want to have an expert in simulation. And so I would like to have it for the layout, for the electronics engineer doing the layout. It should be easy to get a result. So but the current systems, you have to be an expert to use them. You have to be an professional in all signal integrity and all. You have to know everything about this stuff, so that you can configure the program, and then you get the result. And it would be nice to make it easy for you, having the system running in the background, however this will look like, and then you get some information. Say, okay, if we do it this way, yeah, you can do it, but maybe the impedance is not what you expect to have. You should do this or that, and we could give you some hints or advice, maybe to make it better. So that's very vague, I know, but let's see how it works out. But actually, they are really, we are working on this, and I think that's a really interesting topic. Ronald, we could have an external conversation about this. I'm not sure what you're doing. Exactly, if you know something about this, what's there going on at ANSYS. But let's keep. Okay, SIPIMEA. Okay, so you're
signal integrity, power integrity in Europe.
Okay, so that's quite interesting. So okay. So I have a contact to ANSYS now. Thank you.
There you go.
Here we go. Yes.
So to add to Richard's comment a little bit, you know, right now, like Richard mentioned, what's present in the software now is just a straight up export to ANSYS.
Right.
So in order to, you can use it, you'll get a good model that you can take into ANSYS. But as you know, the price difference between ANSYS and Fusion is astronomical, especially depending on how you configure it. So we have that initial step, but as Richard was saying, one of our goals in the relatively near term is to tighten that integration, with the eventual goal of hopefully being able to get insights, live insight, while you're working on the design. You know, I remember there's a professional in the PCB industry, Bogadin, who says sometimes often an okay answer now is better than a perfect answer much later. So you have this trade-off between the quality of your result and how much effort you're willing to put into it. But usually having some initial insights, some initial trade-off ideas is really helpful. And that's one of the things we're hoping will be possible with this integration, being able to offer a little bit more insight to the everyday designer. So like Richard said, they don't have to be a simulation professional. And they, you know, not everything has to go through a simulation professional. You just need to initially, if you have at least enough insight to be able to make some trade-offs, some engineering decisions, that gets you further along in your design process and can get things moving a little bit faster. So that's kind of the goal. Let's see how, like Richard said, how it pans out.
Yeah, right. So we have the computing power in background. So that's something. There are a lot of ideas I could imagine that help somebody to design the board. It's the placement of the components. You could give hints. What is a good placement? What's a bad placement? For example, that's also something that's nothing new to them. But you know, Fusion is a cloud-based tool, and I could do a lot of calculation in the background. Not on your machine, so that's just running the background, and it could give you the information if that's what you're doing is good or not. So, and the same with the simulation here, signal integrity, power integrity, whatever you could imagine. We could just give you hints and say that's good or not, and on the fly. So, as Jorge said, of course it's nice to have a board, and then it's done, and you have to test it, and then you see, okay, I have to start again from scratch because it was not the result I expected. If you get this while working on it, that would be great. Okay, I see. Just as experience. Yeah, right. Yeah, that's something we would like to address, I guess. Okay, yeah. And it's an interesting subject. The topic about simulation on the board is really. Yeah, there's so many things you could do. Yeah, let's see how it works out. Okay, anything else you would add here, would like to know, or if not, then I could go on with a little bit with the yeah. I see you're all experts in in layout and so on, so I'm not sure if it really makes sense what I show you here, but yeah, about the routing tools. I just wanted to show a little bit. Of course, you know, if I route something, yeah, I have here the option, as we have just seen in the slide, something manual routing a differential pair or multiple routes. I just want to show you. So if you start here and say, okay, of course it's clear, route manual, I click the command, I have the wire here, and then I can start routing, decide about wire widths and all the stuff. That's the usual way. It's nice to have some signals routed simultaneously, so I could go and choose route multiple, and now I do just a left click here, start here in between these two, and drag this line over some pads here. You see they're highlighted, and now I do a second left click. Now I stop the selection. And as you see here in the bottom, I see, yeah, I could again add pads or signals to be routed. And the right click starts with the routing. And now I do a right click, and you see my signals jump onto the mouse cursor. Now I could change the distance between the routes. I could also start and just do one left click. Now so it's placed here. Oh, it's a purple. I hope you can see it on the screen. It's a bad highlight color I just chose here. But you see, I can go through this, and then I go there and can go there, and I could even have them completed, routing completed. You see it here. I can type in min spacing, increase spacing, decrease spacing for changing the distance, the clearance between the lines, or I could just press the enter key to complete the route. So I just click enter, and okay, it couldn't route because I don't know why. There are some restricted areas. That's the typical effect. If you show something, then it doesn't work immediately as you expect. But you see, I could route them in one, how do you say, in one stroke, so to say. Let me just show you something else. I want to go here and do a manual routing. From this, I go here. I don't care about width or something like this. I just wanted to show you if I go here around. Sometimes it happens you have to do this and try to find a way through your design, and then I go here. Now you do some cleanup in your board, and there is this smooth route command. So I go here and choose it's quick route smooth. I click activate the command, and if I click onto this here, you see it will be automatically optimized. So it's really nice to clean up in the board. If you have a lot of connections, just click on them and they will be cleaned up a bit. I think that's a really nice tool as well. Yeah, okay. Quick route, well, signals, multiple, that's the same. Quick route is the same for multiple. By the way, how do I get back the air wire we had before? Therefore, I could use the rip up command. I could rip up everything. I could rip up connected. This means I click onto a signal and all the traces connected will be ripped up. I could also do a rip up between parts, different options. Or I could rip up, yes, the signal, and I go here, click here onto this trace, and now it's back in the airwire mode. Or I could also say rip up all, and everything will be in airwire mode again. So that's something, just to show you. That's basically more for beginners what I wanted to show you. Is there anything you would like to see in the layout, for example, or do you have questions about this?
Like no questions for
no
now.
Questions. Okay, no questions for now. So
I can show something if you're done,
if you have something here, sure. Let me just stop sharing. Where's my? Oh, here's the menu. Here it is. Okay.
Thank you. So I just want to say hi to Ronald, Steve, Jason, because this is the first time I meet you guys. So pleasure to meet you. Let me go ahead and show you a couple of things. If there's any questions at any point, just feel free to send them in. So this is a design, an example design that we did about 2 years ago. It's not the most, it's not the top end of difficulty, design difficulty or complexity, but it is a good example of what you may generally find. So this is a pulse oximeter design we did. For those of you who don't know, pulse oximeter is that little thing they put over your thumb or over a finger when you go into the hospital that checks your blood oxygen level. And the way it does is it has two different LEDs in them. One is putting out red light, the other one's putting infrared. And it turns out that hemoglobin absorbs each of those colors differently. So by measuring the amount of absorption between the two colors and the ratio of them, it lets you know what your blood oxygen level is. So that's the operating principle behind this. Basically, you have two LEDs that are in the sensor. The circuit reads the response of the sensor back. So basically how much light gets through your finger onto the other side. In other words, the light that wasn't absorbed by the hemoglobin, that's turned into an electrical signal. It gets processed through the analog circuitry that's in the design, and then that gives out a signal letting you know what your blood oxygen level is. In the simplest case, it also lets you know your heart rate, because you can see the fluctuation in the blood oxygen level as you go through it. So here's a schematic for it. And basically what I want to show is just kind of the organization. There's very much a matter of personal preference when it comes to things like this. Once you're making a design that's not completely trivial, how you organize it can have a big effect on how easy it is to read and how much you'll understand it when you look at it 6 months from now. So these are just kind of some best practices that I wanted to cover. Sectioning off your design, kind of separating it into different pieces is good practice, makes it easy to understand what each specific part is doing. It's okay to have text. You know, give yourself comments the same way you would if you were writing code. You know, why did I choose this value? Why did I make, you know, these changes? So if you look here, I put if a specific sensor maybe is more responsive than, you know, the one I was testing with, then maybe I have to adjust the value of R18. You know, so I put that there just to remind myself, because later on I may come, I test it with a different sensor that I haven't used before, see it doesn't work, and start trying to figure out what happened. So it's just a good reminder to myself as to what's going on. Same thing here. You know, I put the limitations of this right here, the maximum switching frequency I can do. If there's any questions, feel free to bring them in.
Yeah. I have a question.
Yeah.
Is it you have the dotted lines in the schematic? Are these groups?
No.
You define groups? No. Okay.
No, these are just lines. These are just lines, and I made their style to be short dashes.
Okay.
Yeah, that's why you see it doesn't form the full block, and the text
Yes.
is in the center, because this is literally just drawn out. It's manually drawn out. Okay.
So you bring in, you could, yeah, no, I know the answer. It's not fair to ask you, but yeah, can we bring in other schematics from you know? Yeah, I have already a drawing, a kind of design reuse. Is this something you're using also in the schematic here?
In this one, no. But this is Production Fusion now. Production Fusion in a little bit may give you a different answer. So
yeah.
I'm staying within the limitations of Safe Harbor, but I'm hinting very strongly at something here. So if you pick up what I'm saying, you know, you probably will very soon be able to use existing schematics into your Fusion designs.
Yeah, right.
So
okay. Yeah, I was thinking about design blocks, for example, we used to use in Eagle. So if you're in Autodesk Eagle, you know you could use design blocks as well. So that's something. Yeah, that's what I thought about. Okay, but I know there will be a solution soon.
Yes.
Yeah.
And this one on the second sheet is kind of the ideal scenario for it. Basically, you have two filters that are identical. And basically, if I laid out one, I could just, you know, turn it into a block and then automatically have the other. So this would be a good example of using design blocks. I don't believe in the original design I did use design blocks, if I remember correctly. But again, if you look, lots of documentation, why the different things are here. And this particular processing to get the blood oxygen signal is actually not trivial. There's several filters in the chain to make sure that we get a clean signal. Most biological signals are very low amplitude. They require a lot of filtering and a lot of cleanup in order to be able to extract what you're interested in. So if you look, you know, I have this initial low pass to be able to get rid of any DC offset that may be in the sensor, because the sensor always has a little bit of DC offset. So we get rid of that. Oh, sorry, it's not in this one. The offset is here. DC removed is here. So it's just to clean up. Again, make sure no high frequency noise is getting stuck in this. That's also why this next one is here, the notch filter. You know, if I'm in a room and I'm using that sensor in a room with fluorescent bulbs that are the old style, they're coming in, you know, they're actually blinking. The human eye can't tell because they're blinking too fast, but they're blinking. And that signal is strong enough to corrupt my reading of my sensor. So that's why this notch filter is here. It's basically to make sure nothing in that 50 to 60 hertz range can get in. Have another one here, basically another cleanup. Give it a little gain since the signal has been attenuated a little bit, and then another output. So all this is doing is making sure that because this signal is within the range of the human heartbeat, you know, what's the pulse? What's the fastest pulse a person can have? Usually it's around 200 beats per minute or so. So we set up the filters to make sure that nothing beyond that possible range is affecting the signal. So I'm making sure to just limit the area of interest to that. Otherwise, a lot of things can corrupt it because, again, the biological signal, very tiny, very small, but it's surrounded, you know, it lives in a sea of noise. So that's why this is here. Okay. The other thing that this does is it basically alternates between the two sensors. That way I don't have to consume additional IO because the signals are, you know, relatively slow as far as computers are concerned. I can do this, I can get away with this and not lose any type of resolution. Okay, and then finally here's a processor, which was a little STM32. I have its programming interface. It had a screen, or it has a screen. And basically with that screen is that it outputs the waveforms and the data. So this is just showing kind of, again, the importance of writing notes. There's lots of software developers that don't like to write comments. There's a lot of electronic engineers that don't like to document the schematic well. And it's really a disservice to themselves and to anybody else who after them has to deal with this. So by having taken the time to write this in, this helps me in the future. If ever I have to troubleshoot, if I ever have to update it, make changes, I know everything I did and why I did it. And that's valuable. I think there's a question in the chat. I just got a little bubble.
I think that's just Steve telling us he has to jump to another call.
Oh, okay. Nice. Thank you, Steve, for joining us today. Okay.
Yeah, that's live. One meeting of the other.
That's it.
Okay.
All right.
Okay.
Excellent.
Okay, cool.
So
yeah,
go ahead, Richard.
very good. No, I just wanted to ask you, please show us the board as well then.
Sure.
Yeah.
So here's the board. It has the polygon not filled in. A couple of things. You can see these two sides are almost symmetrical. These are the two filters. So again, as a design block, this would have been perfect. You know, you lay one out, you just insert the other one, and you're done. You don't have to redo it.
So a design block could be a schematic in the board.
Correct.
Including the layout already. So if you bring in several design blocks, you get them really as a copy with all the routes done already. Okay.
Yeah. So that was his big appeal. So you can see they're very similar, kind of symmetrical, but you can tell that they're not exactly the same.
Yeah.
Because I kind of hand laid them out a little bit. Especially up here in this little area over here, you can tell that they're different.
Right.
Maybe down here, not so much, because here I did a better job of getting them symmetrical. But and then if you look, you know, everything that was noisy and switching wise, it's all over here. It's all in this area. Okay. So that's where the LED driver is at. That's where all the PWM goes to. So I consciously made sure that I kept them apart because I didn't want anything corrupting my pulse oximeter signal. And that's something that if somebody works in medical, they have to be extremely paranoid about because anything can swamp it, you know.
I see it in on the logo. So it was really a project for World Skills in Kazan 2019. This was I was there as a kind of expert to see how it goes on with electronics there. Do you know, Jorge, about the results? Because the challenge was to I think to complete the schematic and create the board. Um, do you know if there have how did the boards look like? Do you have an idea if they really worked? Because you take care on the noisy side of the layout, put it as far as possible away from the sensors and this stuff. Did you get response from Rudy Hofer about this?
They did get a few to work. I think in the end they had to use the boards I sent them. I think that the routing ones it didn't fly. But I built this, so I know it worked. I had to make sure it worked before I sent them off. I couldn't send them an unvalidated project. So I built it. I made sure it worked, and also sent them this same PCB. So if somebody wasn't able to get theirs routed, the routing machine broke, whatever, they had these so they could still continue with the contest.
So for you who do not know, World Skills is Skills, it's a European one, and there are also country-based skills. So that's something. It's a competition. It's not just electronics. There are a lot of skills from cooking up to I don't know, mechanics and woodworking or whatever it is. So there's a lot of competition there. And there's world skills, so that's something the best in class meet there and have to do a challenge. And the electronics, I think it's not trivial. It's really difficult because you get the schematic, you have to understand what to do, you have to in this case I think they had to complete the schematic.
I gave them like 80% of it, and then there was 3 pieces that they had to design.
Yes. And then you have to create the board. They had to create manufacturing data. The board had been milled overnight. Then they had to put the components on. They also had to simulate before they made the board. They had to simulate the schematic, and then they have the board populated. They had to do the programming for the controller, for the processor. So that's really a big task, and this competition goes over 3.5 days or something like this. So it's really challenging. It was amazing to be there. And it's really hard competition. That's nothing. That's really they program and work for their lives.
It's like the Olympics without the sports. So
Right.
the same level of stress, the same level of intensity.
Right.
But and the same level of like competitiveness. Like they, very cutthroat. If they can create a problem for somebody else, they won't hesitate to do it. Because for some of these competitors, this is basically, the ticket for the rest of their lives. If they win, they have college paid for, they have, per diems, they get a bunch of stuff. If you're a competitor like from a different, from some of the European countries, you get like a trophy and a good job. But if you are from one of the poorer countries, you win your set for life. So there's very much an incentive to win at all costs type of situation. So it is interesting in that regard, and it makes for some interesting logistical conversations.
Yeah, right. Just have to. Right. Okay. Yes. Yeah, that's true. So this year we will see a new competition, World Skills in Shanghai, 2022. It was planned to be last year, but of course now they moved it for a year. Yeah. So let's see how it goes on. We will be part again, so guys will use electronics again for the project. Well, here you're working on some training videos for them, and preparation, of course, is already in progress. And let's see how it goes this time. I'm curious what the new project will be. So I think we have a contractor who works on this, and let's see. it's very interesting. If you have a chance to go there, go there. It's amazing to see these young people working and fighting for their electronic skills. That's really cool. Okay, so anything else we could show you? I think yes.
Yeah,
I
so
think
just to show
Ron had to leave. Okay.
yeah, he did. So I think at this point it's us. It's Autodesk.
Yeah. Yeah. Right.
So just to highlight here, again, the geometry, it's full geometry. It's not just a picture. So it gets taken into account when e-cooling is done, when thermal stress simulations are done, when vibrational stress simulations are done. It's all factored in because it is legitimate geometry and not just a picture.
And it's also a differentiator compared to other systems, because that's really, you really get not just an image, you get all the information you need, as you said, for thermal simulation, for milling out the board. You have everything in place, you have all the information you need. That's a big, it's great to have it.
Excellent.
Okay, cool. So now we saw this. It's a nice project. Thanks for sharing it, okay? And what I learned from this is it's really interesting. It's important to draw clean schematics with a bit of documentation. That's also what I teach to people when they ask me how to do it. Do the extra mile and name your signals. Write a command so that in 20 years you open the board or the schematic and you immediately understand what you have done. Then it's good design.
Yeah.
Okay. That's it from my side.
Okay.
Thank you for joining us.
Do you guys, do you have anything else that you want to cover while we're recording still, or should we wrap this up?
I don't know.
I think we can wrap it up.
Yeah. Okay. All right.
Yeah,
Well,
that's okay. Yes. Yeah.
We'll, if I can figure out how to do this.
You have to click the right buttons.
Yeah. Okay. Yeah. Exactly.
Push the button,
Thank you.
please.
Thank you for that. Thank you for that. Okay, well, thanks to everyone who did join today, and for those of you who will be joining us when we send out the recording and watching this, I hope that you enjoyed what our experts presented today. I learned a few things, and I'm not even into electronics design, but it was just fun to watch you guys working. So when the meeting is completed and we have our recording and everything, there will be a message going out with a whole bunch of links, and one of those links will be to a survey. So we really would appreciate it if everyone would take the time to complete the survey so that we can figure out how we're doing with these sessions and how we can improve them for you in the future. So please take some time to take a look at that survey and share your feedback with us. If you're interested in becoming a speaker for Community Conversations, we'd like to hear from you on that as well. If you have an idea for a session that you'd like to see, or if you would like to host one yourself, one of those links we'll be sending out will be a session proposal form, or you can reach out directly to Sean at sean@autodesk.com and talk about what kind of topics are we looking for and how to structure it, things like that. He'd be happy to work with you on that. We look forward to seeing everyone in the community. We have so many resources available for you to get connected with other people and find answers, talk about whatever you want to talk about. Obviously, our forums, we have several different groups that are available now. Facebook groups, we're out on Twitter, we're on LinkedIn, we're all over the place. We have our student group hub. A couple of new blogs that we've launched. We now have the Community Journal, which is a blog that we are writing for the community to highlight events and members and just information and news about the community. And we also have our Community Voices blog, which is written by the community members for community members. So these are people from within the community who are sharing whatever they want to talk about. Sometimes it's workflows, sometimes it's a personal story, sometimes it's a good tips and tricks little notice. And yeah, it's just great information written by the community for the community. And of course, don't miss out on the next Community Conversations. Check out the Community Conversations website and keep an eye on the calendar for those sessions that you find the most interesting. And we hope to see you in a future one. So with that, I want to thank our speakers and those people who did attend today. Great job, guys, as always.
Thanks, Chris.
Thank you,
Thank you all.
gentlemen.
Thanks.
Thanks, Sean. Thanks, Jason, for being here.